Hello everyone. Now I think you already know some information about the OSI reference mode, right? But in our real network, we often use the second reference mode. This is the TCP/IP. So about this video, we will explain something. What is the similar function between these two reference modes, and what's the difference between the TCP/IP and OSI? So first we have to know the hierarchical structure of TCP/IP and what's the different name of each layer. What's the function of the layer? So if you are interested, let's begin.
Hello guys! Before we talk about the detail of the TCP/IP reference mode, let's have the review of the question about OSI reference model. Which of the following statement about OSI reference model is true? The answer is option D. So let's see what's the wrong of option A, B, C. The data of transport layer is called segment. The data of network layer is called packet. The data of data link layer is called frame. So the option D is correct. And then let's see the TCP/IP reference model hierarchical. As we know about the OSI reference model, we have 7 layers, right? From bottom to up is a physical layer, data link, network, transport, session, presentation, and the application layer. But the difference of the TCP/IP, we integrate the upper 3 layers to become application layer. And transport layer and network layer are very important, so we keep the same. Also, it's transport layer and network layer. And about the last 2 layers, data link layer and the physical layer, we also integrate these 2 layers to become network access layer. So about the TCP/IP reference model, we only have 4 layers. From bottom to up is network access layer, network layer, transport layer, and application layer. Because we know the detail of each layer about the OSI reference model, so now let's say the protocol of TCP/IP reference model is very easy to understand. Let's say the first layer of the network layer. This layer is very important because we talk about so many technologies based on the network layer. About this layer, the main function is deliver packets to the correct destination. If we want to meet the requirement, we have 2 plans have to finish. The first one is a forwarding plan. Forwarding plan is used to help the router or maybe help the layer 3 switch to forward the traffic to the correct destination. So this one we call is routing of packets. Of course, if you want to forward the packets, we also have some entries we have to know at first. So this function belongs to the control plane. About the control plane, we have to maintain of the route. So we will talk so many protocols like OSPF, BGP, static, something like this. So these are 2 main functions of this layer. And the main protocol we have to know, the first one is IP. The IP we already talked some detail in the OSI reference mode, right? And the IP will indicate the format of network layer. That means after we do the encapsulation of the network layer, we have to add the layer 3 header, right? So what's the information we have to add to? For example, like the source IP address, the destination IP address, something like this. This is indicated by the IP protocol. And the second one is RCNA. After we establish the connection between different devices, we have to test the connection is ready or not. The process is I send some message to you, and within the time you can give me a reply, we think the connection is ready. So what's the packet I will send to you? This packet we call is RCNA. And the next one is IGMP. IGMP usually is used in the multicast scenario. We have 3 types of packets. Indicate the first one is a unicast. That means point to point. And the second one is multicast. That means one point to multi-receiver. The third one is broadcast. one sender and all the destination can be received. So we have three types. And IGMP usually is used to the multicast. And the next layer is the transport layer. About this layer, we provide end-to-end communication, and we have some mechanism like data integrity check. When I receive the packet, I will check someone changed the information or not. If I receive the packet, some bit is wrong, I will ask the sender to give me a new one. This is the second characteristic of error retransmission. And the third one is data reordering. Because all the packets we have the sequence number, so maybe some packets will go to the destination faster than some packets. We will reordering the packets according to the sequence number. And the typical protocol is TCP and UDP. Of course, if you want to use the mechanism of the first part, we have to choose the TCP. UDP cannot have this mechanism because if we want to use UDP, that's because we want the packets can be transferred as faster as possible. So they are different protocols definition. And the next layer is the application layer. About this layer, we integrated up 3 layers of OSI reference model, so this layer will handle the specific application details, something like the remote access and the resource sharing. And the typical protocol like Telnet and SSH, this is used to remote log in the device, then we can do some configuration. The second one is FTP and TFTP. This is used to transfer some files. And SMTP and POP3 is used in the email, right? And the next one, SNMP, is used to manage some devices. And HTTP, I think everyone familiar with this protocol because maybe you open your browser like Google, like the others. We use this protocol to get the message from the page. So they are typical protocols. And the last layer is network access layer. About this layer, the main function handles the details related to the transmission medium. Because we integrate the physical layer and the data link layer together, so this layer is directed to connect with the cable. So we will use to indicate the physical lines and interface, and also the link layer communication. The main protocol we will talk about like Ethernet. This is used in the LAN network. In the small coverage network, we will use Ethernet. And the PPP is usually used in the WAN network if we transfer the packets in the long distance. And the third one is the frame relay. So here are the typical layers. And the last also I will provide one question for you. Which of the following layers does the TCP/IP reference model include? From option A to option F. I think it's very easy for you to get the correct answer, right? This is a multi-choice. If you want to know the answer, please focus on the next video. Thank you.
Now I think you already see the training video, right? Also, let's have a brief summary for you. About the TCP/IP, we have 5 layers, right? From the bottom to up. The first layer is physical, then is a data link, and the next one is a network, then is a transport, and another one is the application layer. So between the different layer, it is a little different between the TCP/IP and OSI. And the next one, the typical protocol between the TCP/IP, like the data link layer, we will use the Ethernet, and the network we usually use the IP, ICMP, and about the transport layer, we will use the UDP and the TCP. So if we use the TCP/IP to forward the traffic, and we will do the encapsulation for the packets. add the header of the data link layer and the physical layer and something like this. So finally, the full traffic will be forwarded out. So about this part, that's all. Thank you.